Hello and welcome to this session. Today, we will focus on Learning Outcome 2. Understand a common data analysis lifecycle of your choice. In this session, we will explore how raw data is transformed into actionable insights. By following a structured data analysis lifecycle, we can systematically move from data collection to data cleaning, analysis, and ultimately, presentation of findings. This approach ensures that the analysis is efficient, accurate, and meaningful, allowing us to make informed decisions based on evidence. Together, we will break down each stage of the life cycle and see how data becomes a powerful tool for decision-making. Data collection is the first step in the analysis life cycle. It involves gathering raw data from multiple sources. These can include databases, surveys, and sensors. The goal is to collect relevant and accurate data. This foundation is crucial for the validity of the analysis. Data cleaning or pre-processing prepares raw data for analysis. This step corrects errors and handles missing values. It also standardizes formats for consistency. Accurate data cleaning is essential for reliable results. It ensures the dataset is ready for exploration. Data exploration examines the cleaned data. It uses descriptive statistics and visualization techniques. This phase helps understand data structure and patterns. Insights from exploration guide further analysis. It identifies potential areas for deeper investigation. Data modeling applies statistical or machine learning models. It uncovers patterns and makes predictions. Choosing the right model is crucial. Training and evaluating models ensure accuracy. Modeling transforms data into actionable insights. This phase interprets model results for stakeholders. Clear presentation is key. Use charts and reports to communicate findings. Effective interpretation leads to actionable decisions. The goal is to make insights understandable and useful. The CRISP-DM model is a standard framework for data mining. It consists of 6 phases from understanding to deployment. Each phase is iterative and builds on the previous. This model aligns analysis with business goals. It's widely used across industries. The first phase focuses on project objectives. It involves stakeholder analysis and requirement gathering. This ensures alignment with business goals. A clear understanding guides data collection. It sets the foundation for the entire project. This phase collects and assesses data quality. It provides initial insights into data patterns. Understanding data characteristics is crucial. It identifies potential quality issues. These insights inform the data preparation phase. Data preparation cleans and integrates data. It involves transformation and feature engineering. This phase is time-consuming but essential. It ensures data is ready for modeling. High-quality preparation enhances model accuracy. Modeling selects and trains algorithms. It evaluates performance using metrics. The process is iterative for refinement. Successful models meet business objectives. This phase transforms data into insights. Evaluation assesses model alignment with objectives. It involves performance testing and stakeholder review. Validated models are ready for deployment. This phase ensures models are useful and relevant. It confirms their business value. Deployment integrates models into business processes. It includes user training and performance monitoring. This phase realizes the business value of insights. Continuous monitoring ensures ongoing effectiveness. Deployment makes insights actionable. CRISP-DM and SEMA are both data analysis models. CRISP-DM focuses on business goals and is highly iterative. SEMA emphasizes technical steps in data preparation. It is less focused on initial business understanding. Both models offer unique strengths. KDD provides an end-to-end process for knowledge discovery. It focuses on technical data mining steps. CRISP-DM emphasizes business integration and iterative refinement. KDD is popular in academic settings. Each model has distinct applications. Understanding inputs and outputs is crucial in CRISP-DM. Each phase builds on the previous, ensuring continuity. Inputs range from stakeholder insights to data sources. Outputs include reports and prepared data sets. This structure ensures project success. Conclusion: understanding the CRISP-DM process enables organizations to make informed, data-driven decisions. By providing a structured framework, the model ensures that data analysis aligns with business objectives while maintaining data integrity throughout the process. If you need any help, just WhatsApp 074-8436-1688. Our team is always ready to assist. Thank you for your attention, and we look forward to seeing you in the next session.